Okay. Another 1 minute, we'll start the recording. Just another 1 or 2 minutes. Yes, can we start the video recording? Okay, so we'll be starting. Greetings and good evening to one and all. On behalf of the organizing units, ACM Chennai, IEEE Computer Society Chennai, and CSI Chennai, I would like to extend a warm welcome to our eminent speaker, Mr. Rajeev, members and my colleagues from the organizing units, and delegates joined the Google Meet session, and those watching the YouTube streaming. AI, ML, DL, they have become buzzwords nowadays. Everyone tries to understand and implement solutions using these technologies. All of us are aware that algorithms take center stage when we talk about machine learning. Vast majority of AI projects don't deliver or fall short of expectations. One of the reasons for this shortfall in expectation is lack of understanding on end-to-end process. Effectively managing people, process, and technology is an important item to be successful in data science. So most of the current courses or the lectures, this concentrate more on algorithm instead of the other two aspects, that is the people, process, and technology. So in this talk, we try to decipher the end-to-end machine learning process all the way from data collection to deployment and continuous monitoring supported by use cases. So with this brief introduction of the topic, let me now introduce our speaker, Mr. Rajeev. Mr. Rajeev is known to us through IEEE for the last 6 to 7 years, and he has been contributing articles and snippets in the newsletter and very actively engaged in supporting educational institutions in board of studies and so on. And of course, he is generally available, makes himself available for technical presentations through some of the societies. Most of the IEEE societies, he has been very much extending his valuable time. So Mr. Rajeev is a hands-on technologist with about 23 years of experience. He is an enterprise architecture with diverse experience in technology, engineering, domain, and research. Presently, he is part of the artificial intelligence program in TCS, and his primary responsibilities include delivery of architecture focused on AI and building capabilities around shallow learning, deep learning, and natural language processing. With this brief welcome note and short introduction to the subject and the speaker, let me invite Rajeev to take over and enlighten us on ML algorithms and its applications. Over to Mr. Rajeev.
Thank you, sir. Hope you're able to hear me.
Yes.
I'm just sharing my screen. Let me know once you're able to see so that I can start, So let me know once you are able to see my screen.
Yeah, screen is there, but can you switch off the message, bottom message?
Yeah, just a minute.
Yeah. Okay, fine.
So just want to give a talk on machine learning beyond algorithm. Why did I choose especially beyond algorithms? The reason was very simple, because very few people understand the end-to-end of machine learning. In order to be successful, in a project, what all do you require? And actually, it is far beyond algorithms, and that's what we'll have to take a look at today. So I want to give a brief agenda of what we are going to do. Why do some projects fail, or majority of projects fail in the ML space? How do people process and really forms the core of any successful project? What are the elements of ML systems? The roles MLOps plays, the different types of operations that are involved in the end-to-end of machine learning. We'll look at technical stack. We'll look at the MLOps architecture at high level and the stages of CI/CD pipelines, and then the AI hierarchy of needs, ending with a conclusion, So now coming to why majority of ML projects fail, this is a survey that was conducted in 2019. Even though it's 3 years old, a lot of things, what is discussed here matters today also. So if you look at that, the failure rate is very high in terms of machine learning projects. Or failure, when you talk about failure, it could be due to even lack of expectation also. You expected something you did not achieve. In that case also, you consider it to be a failure, So a lot of these surveys have shown that a lot of ML projects comes at the stage of proof of concept or gets deployed but do not get adopted extremely well, And why? The reason for that, we need to look at the next stage. So there are 3 things when you look at a project, actually. In order to be successful, the synergy between people, process, and technology is very, very important, When we talk about machine learning and algorithms, we are predominantly talking a small space in the technology side of it, actually. When it comes to people and process, we do not talk much about it. But for a project to be successful, all these 3 has to work in tandem, actually. So that is why you look at the Venn diagram, the Venn is at the centermost point where all the 3 fields meet, and they are, they are successful by each of them, and synergetically also they are successful. It's very, very important this concept to be understood actually. Now let us look at the hidden technical depth. So this was a Google paper which was published a few years back actually. If you look at here, the ML code is in the middle and it's a very small portion. There are much more things like all the way, because you are learning, when you talk about machine learning, it is learning from the data. So obviously things like data collection, data verification, quality assurance, data lineage, so many things comes into picture, feature engineering. So data by itself is a very, very large field. I always used to say in data science, data is 80% and science is 20%, because unless you are able to tackle data, you cannot tackle science aspect of it. So it's very, very important that you understand the entire spectrum of data and things around data. Then there are other software engineering practices, debugging, configuration management, automation, and things like that. Then coming to machine learning beyond the code per se or the algorithms per se, model analysis, model management and things that comes, Then data governance aspects like metadata management, process management and other things comes. And then serving infrastructure, serving and monitoring, very important, very important in the industry as part of the operations aspect of it, So here it is very clear that the ML code by itself plays a small portion of the overall cycle of that. And that is why this paper is very, very important, because it's about hidden technical depth in machine learning system. It's not about code, your machine learning code alone. There are a lot of things around it, and you have to bring all those things together actually, Now looking at some of the roles, one of the reasons why I see in some companies it fails is that today, if you look at the data science field, there are different roles: data scientist, machine learning engineer, or ML ops engineer, backend engineer, DevOps engineer, software engineer, data engineer. There is a growing tendency in many companies that, one or two people try to play all these roles. And in my opinion, it is little risky, because there might be very intelligent people who can play most of these roles together. But predominantly, if you look at the overall industry per se, there are only very few people who can do that. So it's better that you understand the difference of these fields and you still have people play that specialist role. And a few cases, few people might play a generalist role. And this is very important for projects to be successful. In startups, I have seen that probably one or two people plays this entire role, and which makes it very difficult for them to manage the end-to-end of this stuff, and which can increase the technical depth and failure at the overall spectrum of it. The entire problem starts with agile, because the problem is, I like this slide because of the reason that, because of you, agile, I need to learn, all these ops, DevOps, data ops, IT ops, model ops, SecOps, security operations, AI ops, ML ops. It's very, very important. Can one person or couple of people learn all this to make the project to be successful, which is very, very difficult actually. There might be some brilliant people, but I would say that it is a team activity rather than an individual activity in order to be successful in the long run, And how many roles do you play in the team? That depends, that depends on the complexity of your ML projects. But 4 to 5 roles might be required minimum in complex projects, or if not more actually. So now I want to come up with the end-to-end of ops in machine learning. There are different aspects when it comes to machine learning, business operations, data operations, machine learning or model operations, IT operations, sustainable operations, is this project sustainable or not? Human-centric operations, security operations, and drift. So your model getting drifted and stuff. Now, if you take look at each of them, what way business ops is very important, business operations, because ultimately technology is only a means to solve a business problem. So you should see technology always as a means to solve a business problem. More important is the business problem that you are solving. Is the problem I am solving adding value to my organization? In what form the value is added? Is the project doing optimization, or is it doing creation of value, or is it basically leading to an ecosystem play? This is very, very important, because if you look at the entire research community, I always used to say there is no innovation without invoice. Ultimately, any project in an organization is for generating revenue. You cannot constantly be a cost function. So you should really understand how the machine learning field is going to add value to your organization. Is it cost optimization? Is it value creation through new features and stuff? Or is it just value addition to an existing application? Or is it going to increase your ecosystem play overall? This is very, very important, because unless we know the value, what the project is going to bring, or the machine learning is going to bring, we might be starting a project which is mostly from the perspective of research. It will die down sooner or later, because as I said, there is no innovation without invoice. Everything is generated for revenue, So very, very important. Now coming to data ops, as I said, data forms the core of this field. Data is 80% and the science aspect is 20%. So whenever you deal with large amount of data, you have to deal with a lot of aspects like data governance. How do I monetize the data? How do I automate feature engineering? How do I use synthetic data generation for solving the problem when I don't have sufficient enough amount of data? And in each of these fields, if you take data governance, so many aspects comes into picture, quality of data, basically like lineage of data, data cleanliness, profiling of data. So much of stuff comes into this picture. So data ops is very, very important for a successful machine learning project, actually. Then you come to ML and model ops, actually. Again, the ultimate aim of any operations is automation. So obviously, one of the biggest aspect in the entire field of software engineering is what is called CI/CD, which is continuous integration and continuous deployment. How do I take the code from all the way a developer checking in a code to a build process, basically verifying the build, then taking it to deployment, verifying that the models are working fine, ensuring that the models are not causing any major issues and stuff. So this end-to-end process involves, automation, and that's where you get into automation process like CI/CD. Then, model management. How do you manage the entire model governance? How do you basically take one model off and then put another model and ensuring that model do not cause any issues and stuff. So there is a lot of automation involved here. Flexible deployments. So there are different deployment models like canary deployment. Then concepts like A/B testing. A/B testing is case where you have two models running in parallel in production. What you do is that your traffic is split in such a way that 50% goes to model A, 50% goes to model B, and you evaluate the model. And depending on how the performance of the model, you will replace one model with a newer model. Very, very important, especially in cases of recommendation engines and things like that. You might have one or two models or even three models running, where the three models will do recommendation, and based on user feedback and feedback loop, you will decide which model is not performing well so that you can replace that. So that entire spectrum falls in the field of ML or model ops per se. Then the traditional, IT ops per se, where your deployments could be, traditional bare metal system deployments, or it could be that your application is cloud ready, in which case it is considered to be maturing. The traditional is the old school. Maturing is that you are moving towards the cloud aspect of it. Then you have what is called cloud native, where it is considered to be a modern application, and then you get into the ultimate stuff, which is called hybrid, which is basically considered the future of. So when you talk about cloud, you have private clouds and public clouds, So hybrid is somewhere in between, where half of your infrastructure is in public cloud and probably another half is in private cloud. Very, very important because pure data center, on-premise data center is also not going to work. Pure cloud is also not going to work. So it is always a compromise. And how your machine learning models are deployed matters here a lot, Now coming to sustainability, obviously, whenever you use any technology, the ultimate goal is to ensure that it is basically sustainable, So we have to look at compute optimization. Is my machine learning model taking a lot of compute power or power, very, very important. How do I optimize it and things like that, Then, basically other areas of sustainability, what is called net zero ML and things like that, So very, very important because there are many areas in sustainability, what is called low precision compute and all. I'm not going to go into that, but we will discuss how do I deploy a model which only requires very less compute, Ultimate aim is very simple, shrinking your ML so that, your carbon footprint is very less. And sustainability is gaining a lot of traction because if you look at the data center power consumption, has been increasing tremendously. And one big contributor to this is machine learning. So the question comes is, how can I use, better hardware and softwares to ensure that the compute requirements are minimal, So that comes under the sustainability of operations. Then human-centered operations, how do I deal with typical problems which even humans deal with, So things like bias. The data that I have collected has inherent bias. So if the data collected has inherent bias, obviously the learning algorithm will learn that bias, Simple examples could be that, gender bias, So people are applying for jobs. Now, when the algorithm picks up the candidates for certain jobs, it is picking up based on the bias that it sees in the data. It might be picking more men compared to women, because the data was inherently biased, and hence that bias comes into that. Then areas like ethics and fairness, how it will be fair to every type of people and stuff like that, Then areas like explainability, and interpretability, very, very important. Many models are not explainable. So this is where I always like a term called, basically like competence without comprehension, So how do algorithms achieve extreme competence, without actually with actually lack of comprehension? Very, very important, because there are many fields where legally you are supposed to explain. If you reject somebody for a loan, you are supposed to explain as to why he or she is rejected for the loan, and very, very important, especially when it comes to legal. So if you use machine learning for certain fields like finance, or areas like surgery, or areas like life sciences, judiciary, you need to explain. Very, very important. Explainability is a very important consideration in that, actually, Then responsible, because ultimately we want algorithms to be responsible. So these are some of the human-centered factors which the entire solution should imbibe, Then coming to security aspect of it, because since the data are collected from a lot of data is collected from public domain, we need to ensure that the data is clean and it does not have unwanted bias or things like that. There are you could have information poisoning, concept like information poisoning, where the data is poisoned over a period of time, and that data can be, lead to a lot of problems. So if the data is not good, the model becomes problem, because ultimately you are learning from the data. So data security, model security, your application or service security, or the ecosystem security is very, very important in the overall end-to-end machine learning. So we are getting into fields like federated learning. In federated learning, you are not sharing the data. So let us say we have 1,000 hospitals. So the hospitals are not willing to share the data. What they will do is that they will learn a model locally, and then they will transmit the model to a centralized location where you will do concepts like weight averaging, and the new model will be shared with all the 1,000 hospitals. It is very, very important in this type of hub and spoke models to ensure that some of the spokes are actually not playing around with the stuff, to influence your model, model and outcomes, very, very important, because through that model poisoning or data poisoning, they actually can influence how the model works, so in any distributed trust, it is the we assume that majority of the participants in that distributed ecosystem are genuine. If that assumption is taken out, basically you could spoil that. Very, very important, especially in security operations perspective. Then areas like drift operations. See, one of the assumptions we always make is that past equal to future. Past is not equal to future. Past is probably can be approximated to future depending on type of data that and type of machine learning that you use. You saw a cat 30 years back, that cat more or less remains the same today also. So not a big issue, in which case you can make an assumption. So if you are writing a classifier, machine learning classifier for cats and dogs, yeah, if you have taken a data from 30 years old and you project it to the next 10 years, it still looks okay. But is that possible with share data, share market data? Answer is no. The share prices constantly change. They are very sensitive to time and other aspects, So you can't assume past equal to future in that type of a case. So it depends. So we have to understand how the data is drifting over a period of time, how the concepts are drifting, how the models are drifting, and how do we end up building very adaptive systems which understand this change. See, data could drift, concept could drift, model could drift, people's taste could drift actually, which is in turn forms the concept drift actually, because dependent variables and independent variables could drift. And these are all very, very important. So if you look at this end-to-end ops is very, very important for any successful machine learning project. Now, quickly looking at a technical stack, this is not the full stack, but if you look at the overall machine learning per se, huge things all the way from silicon. If you look at from the bottom to the top, silicon, what type of a precision the hardware supports, FP32, FP16. So silicon, if you look at that general purpose hardware like CPUs, all our laptops are CPU bound. Some of us can have integrated graphics, or some of you might have a gaming laptop which might have a discrete graphics. Then you have tensor processing unit, vision processing unit, STTL hardware, FPGA, field programmable gate arrays. Then specific hardwares like ASIC, Goya type of hardware, so which is application specific integrated circuits and stuff. So ultimately your machine learning solution is deployed on one of these silicon, and each silicon has advantages and disadvantages. So understanding that, understanding the precisions, as I said, sustainability. Deploying a model with FP32 and deploying a model with INT8, the cost could be 1/3. But then what is the difference? Why not all models can be deployed as INT8? Because whenever you reduce the precision, your accuracy goes down. So it's always a compromise between throughput, latency, and accuracy, and you need to understand the hardware. Then the kernel aspect of it, what all the mathematical libraries or the core libraries that are behind the scene, math kernel library, eigen libraries and stuff which are running, you will not mostly, unless you are a low-level systems engineer who develops this, you will not understand this because these are all abstracted away on a framework like TensorFlow or PyTorch, then graph model compilers and language compilers, very, very important. As I said, you write the code in a certain language. You have a graph behind the scene, execution graph, and those execution graphs are optimized for specific hardware. So if I have an accelerator like a GPU, how can I parallelly run the model on that GPU? And normally graph compilers or model compilers or language compilers take care of it. You will not know it at that. Then the framework that you are dealing with, typically you will tend to use 2 or 3 common frameworks. So scikit-learn, it could be TensorFlow or PyTorch or OpenVINO, and then other frameworks like ONNX runtime or ONNX and stuff like that. So depending on your stuff, you will use that. So then the deployment and the MLOps aspect of it, how do I deploy my model? Is it TF serving, TensorFlow serving, or I'm using OpenVINO model server, or I'm going a custom stack like Nginx plus Flask, I will deploy my model through that. Or I want to use more of containerized stuff, Docker plus Kubernetes. Or I want to custom build it through Kubeflow, MLflow, and then deploy it into an Nginx plus Flask, or use a cloud stack. Like, if I'm in AWS, I will use SageMaker for the end-to-end. Or I can use Vertex AI in GCP and stuff like that, Then if you go further in the stack, topologies and models. So what type of algorithms do I use? It depends on the type of data that you deal, whether you are dealing with structured data or you are dealing with unstructured. In unstructured, it could be images, videos, or it could be voice-based data, or it could be LiDAR or time scale data. So many, depending on the data and the algorithm that you choose will differ, So here itself, you can see typically XGBoost and logistic regression, you typically tend to use with structured data, whereas when it comes to computer vision, you tend to use neural networks, which are CNN based, where ResNet, VGG, YOLO, and all comes into the SSD comes into picture. Now, if you are dealing with time-bound data, which have correlation to seasonality and stuff, you deal with algorithms like ARIMA. And then now you have NLP, natural language processing, where you are dealing with unstructured text, You use something like transformer-based models like BERT and stuff, Then you go into developer tools. Developer tools can be divided into 3 or 4 segments. One is the integrated development environment, IDE. So you tend to use something like Jupyter Notebook, Visual Studio, or DL Workbench, or it could be PyCharm if you are using a Python programming and stuff. Then you have annotation tools. Depending on the type of data that you annotate, the tools might differ. So CVAT is for computer vision, So CVAT stands for computer vision annotation tool. And then there could be another annotation tools. Then you have profiling tools. If your machine learning is taking long time, I want to profile and understand why is it taking long time, So typically you tend to use Intel's VTune type of system to understand why my program, Python or C++ program, is taking long time and stuff, Then you have Netron type of tools where basically if I want to view my model, how the model graph is, you use tools like Netron. So all this technical stuff that we discussed all the way from silicon to developer tools was designed to finally solve a business problem, So it could be a classification problem. It could be dialogue systems, conversational systems that you build for your business. It could be image recognition system, speech recognition system. So the top box is very, very important because all the bottom boxes are actually to support the top, which is business, Now coming to one specific area like MLOps, the complexity involved could be very high here. So this shows you all the way from the data pipeline to the model pipeline to the deployment and stuff. So this diagram shows you the interaction that are happening between people, process, and technology. And very, very important to understand, because ultimately it is any successful project brings in the synergy between people, process, and technology. And when you talk about process, there are quite a few processes that are involved. So all the way, as I said, from the data source ingestion onwards, connect to raw data, data extraction, transforming and cleaning, feature engineering, data ingestion aspect of it, data analysis, validation, model training, model validation, model export. So I'm not going to go through this. So if you look at the entire field, it's a very, very large field. This is not the overall stuff. This diagram is actually oversimplified. If you bring the entire end-to-end of the MLOps, which I showed you, this diagram can become pretty complicated with different roles people playing and stuff like that. I'm not going to go through this, but if you want to take a look at it, there was a very nice paper. I have given the link here actually, which you can take it at, which gives you an overall detailed MLOps aspect of it, And this is a little more simplified stages of the CI/CD automated pipeline, So source code, packages, how do I build packages? How do I build automated pipeline? Build, do the trained model prediction, monitoring, and then this entire loop. It's not linear. It is circular in nature, Very, very important to understand that. I'm not going to go through this. I have given the reference. You can take a look at it. I can share the slides, not an issue. So before just the conclusion, let us look at what are the AI hierarchy of needs. So this was a presentation I took from somebody, AI hierarchy of needs. So which all the way from collect, move, store, explore, transform, aggregate, label, learn, optimize, things like that. So here also, the person talks predominantly about technology, not talk about process and people much actually. But real hierarchy of needs, if you look, we have to have all of them in that actually. So this diagram could be very complicated for if you include all the way from process, people, and technology into that, and that forms the core of the AI hierarchy of needs. Very, very important for us to understand that, because in industry you have to deal at that level. It's not purely dealing at algorithm and then getting away that. So as a conclusion, I just want to go through the fact that, in order for a project to be successful, the synergy between people, process, and technology is important. If you are not able to achieve that synergy, the chances of failure is very, very high in this type of project. I would conclude my session with this simple thought process. How do you bring synergy between people, process, and technology? And how can our educational institutions basically teach how the industry works in ensuring that there is synergy between people and process and technology, not purely from the algorithm perspective alone. With that, I will wind up, and now we can get into questions and answers. Yeah. So, sir, how do you want to go? Shall I start with the questions that was shared with me?
Rajeev,
Yeah.
Q&A session will be initiated from our end.
Okay, okay. Sure, sir. So I have finished my presentation. So now we can spend another 40 minutes for Q&A,
Okay, sir.
Yeah, sure.
And thank you. Thank you very much for your excellent presentation, sir. We have received many questions through our registration. So I will read one by one and please give your answers, sir.
Yeah, sure.
So how machine learning can help in making prediction of financial systems?
Yes. So financial industry, algorithmic trading, So when you hear the fields like algorithmic trading, it is actually the machine that is making the decision as to whether the prices of share goes up or not, So risk analysis of companies, risk analysis of companies involves, machine learning. So there is a lot of areas in finance which internally uses machine learning. Risk prediction. It could involve things even like money laundering activities. Our companies. See, today, if you look at the Bitcoin, why is things crashing and why we were not able to predict that people are colluding to basically cause so much of crash in the Bitcoin market and the stuff. So there are quite a few areas: algorithmic trading, risk assessments, anti-money laundering aspects of it, and then there are so many areas. So you can search for it and you will get it. Hope that answers.
So thank you very much, sir. Next question: how to start machine learning?
Okay, that is a little tough question to answer because there are so many ways to do that. Let me see. I did prepare some questions, so let me see if let me know if you are able to see my screen.
Yes, sir.
Okay, so that was one question because I saw it was repeating and hence I took some time to spend. So if you look at, there are different ways to learn actually. Working with a mentor is obviously the best possible solution, but many people do not get that. So if you have a mentor in your organization or industry or in academia, some of your teachers, that is the best way I would say, interact with them, start solving problems there. But other ways, if you are a self-learner, you have methods like, attend MOOC courses like Coursera, LinkedIn, LinkedIn Learning or NPTEL. NPTEL is the Intel, like India version of the massive online open source courses, So there are quite a few courses on machine learning. So today material is not the problem. Today, the problem is your attitude to learning, I don't think today data is the problem actually. Like content wise, you have everything. Or you could follow what is called self-learning through influencers, GitHub of some of the. So I have shown a couple of GitHub links here. They have solved a lot of problems and they have given you, how to solve the problems and stuff. Or you will have to go through a paid course. If you are not a self-learner, you need a trainer by itself, you will have to attend courses which are trained, and it could be on-premise also, where you go to a center and learn from that, or understand through people's blogs. I have written quite a few blogs in this field. If you want, you can take a look at it. So two of them I would like to explain. I'm not the only blogger. There are thousands of bloggers. So you don't have to follow me. But what I'm trying to say is that we have spent considerable time. So if you look at that, I have a blog on machine learning journey part 2, and there is one which I wrote almost 5 years or 6 years back, which is called machine learning journey part 1 actually, which is a very large one actually. If you look at that, it's a very huge blog and probably can take hours for any person to digest. It talks about algorithms, so many lower level aspects, visualizations, So take a look at it. There are such blogs because once you read and understand the blog, what you will get by reading a blog like this is that you will get the spectrum. It's very important. If you want to connect dots, first you should know what are the dots to connect, So whether I know 3 dots or I know 5 dots. A person who knows 3 dots will be able to only connect 3 dots. A person who knows 5 dots will be able to connect 5 dots. So this spectrum of machine learning is so large that, even if you spend 20 years in this field, you might still, there might be areas where you still do not know certain aspects, So that would be my answer, sir. Hope it answers. So you can take a look at, or you can learn through company portals also, or Kaggle. This is a good site. If you are, this is, let me show that actually, because it's important to, why this is good is because it is a simple stuff actually. Because so here, if you see here, they teach you from the intro to programming languages, and they have taken Python as the choice. You don't have to stick to Python. Data science, you can use Julia, Java, but Python is the largest ecosystem. So predominantly, I would say 60 to 70% of people tend to use Python, but there are other languages like C, C++ and stuff. Introduction to machine learning, then pandas, which is called the data frame, especially if you are representing structured data, how do you load the data and things like that. Intermediate machine learning, data visualization, feature engineering, SQL, very important, because a lot of your data might be lying in a relational database. How do you bring it, advanced SQL, things like that. Introduction to deep learning, then how do you deal with image-based data, where computer vision comes in, time series, concepts of data cleaning, intro to AI ethics, geospatial analysis, very, very important, because the data, could be more complex, you could have satellite-based, data and that. Then machine learning, explainability, and reinforcement learning. So this is very important. So what I can do is probably cut and paste some of these things into the chat, so that if you want to pick it up, or I can share it with, Mohan sir, and you can get it also, or either way, it doesn't matter. So let me put it in the chat. Yeah. I hope that answers, sir. I have given a small answer, but it's a large field and very, very difficult to explain it in very detail. I hope it covers what you are looking for.
Okay, sir. Thank you. The next question is, what are all the basic ideas to write good algorithms in machine learning?
Okay, so if you are a person who's looking to write algorithms, I would say fundamentals of math, stats, and probability is very, very important, because a lot of algorithms are written on top of that. Because if you understand any algorithm for that matter, ultimately it is some form of a minimization or maximization type of a function per se. I have an outcome. I want to classify dog and cats. What is the best way that I can classify both of them is a question. So my suggestion would be to start with maths, and I think I did take some areas where so if you look at the maths for machine learning, there are some courses available, or there is a dedicated book available here. I would be a little careful going through the book, because this is purely mathematical in nature, which might be useful for you, especially if you are going to research and your main aim is to do algorithms. So this is a very detailed book, freely available. Unless you get the fundamentals of maths, stats, and probability, getting into developing algorithms might be more difficult actually. So if you want to go through this stuff, you can take a look at it. And once you start understanding that, areas like optimization, whether be it convex optimization, concave optimization, or things like that, then you can start getting into how do I develop algorithms to identify patterns at minimal cost, because ultimately the algorithm should not take up too much of compute power or too much of time, in which case it will never be successful. So that is why a lot of simple algorithms are still considered very successful. I hope that answers, and let me paste the link for you for the people. I hope that answers, sir, or any specific questions, additional questions on that aspect.
Yes. No, sir. We'll move to the next question, sir.
Yeah.
Would you please provide roadmap for learning machine learning?
Yeah, I would club that into the first question, where I have given clear roadmap in some of the blogs.
Yes.
So please take a look at it. If you have anything, you can contact me through LinkedIn or something. I can always guide you. As I said, if you can find a mentor close to you, that is the best thing possible. But a lot of people can't do. So hence, I would say 90% of people self-learn machine learning. And that is where it gets tricky, because it is a large field, and depending on how good you are, you might lose interest very fast or not. It depends actually. Yeah. So I would say that go back to the first question, where that gives you, what are the steps involved in going step by step to learn the field.
Thank you, sir. The next question is, what are the typical applications of machine learning in environmental management and sustainable development in general?
Yeah, I looked at that question. So there are many areas in the sustainability. I'm not basically. So if you look at today, sustainability as a field is pretty important actually. So whether it is water management, land management, any area, there are quite a few areas I know that are being worked actually. It is not my specializations per se, but if you look at environmental science per se, I would say climate, all the way from climate, water, all the sustainability goals that are listed, have some area of machine learning involved actually. So what are climatic prediction and all are not new actually. So they are a very old field actually. They are probably 40-50 years old field. But are we perfect? Answer is no actually. So waste management. How do you apply data science for waste management? So today, if you see the sorting of waste, there are automated sorters. I don't know whether you have seen when the waste is put onto conveyor belt and it goes through that. There are very intelligent sorters which can basically replace segregate plastic versus metals versus different types of metals and stuff actually. So waste management is one area where a lot is done on this field. But just to give you I'm not an expert in that field because I've rarely worked on it, but you can search for it, or if you need further help, you can connect me through LinkedIn and I can always help you out.
Okay, sir. We'll move to the next question. How can we strengthen ourselves on the foundation of machine learning?
Yeah, I would say take a course like I showed you the Kaggle one. I would say first attempt that, spend 1 or 2 weeks in a couple of courses. That will help you. And one thing you should understand, this is a field with application. Like you need to try hands-on. The reason is that you can learn swimming. Think about swimming. You can always buy hundreds of books and learn swimming through books. But the time you jump into the water, you will start seeing singing. So it's very, very important. Data science is also feel like that. The more problems you solve, the better you become at it. Very, very important. So just follow some of the links that I have pasted, and I'm sure that over a period of time you can get it. Don't think that you can master this field in an year's time or two. You can get to some good shape in 1 or 2 years, but in order to master both the breadth and depth of this field, it could take decades.
Thank you, sir. The next question is, what is machine learning in data science?
Yeah, so data science deals with basically identifying patterns in the data, analysis of data and stuff, and machine learning algorithm plays a major role. So all the patterns that you find today are basically through machine learning only. So they are very intertwined field actually. So be it using machine learning for data annotation, data cleaning, or basically identifying the data lineage automatically, things like that. Yeah, they are intertwined field, and machine learning algorithms are used a lot in the data science field. Data science has other areas also, what is called exploratory data analysis and stuff. So a human could explore the data to bring in more insights into that, and so those are where manual aspects comes. But there is a lot of algorithmic aspects also. You have a huge amount of data and you want to cluster it and see how the clusters are forming. You use a clustering algorithm there. Yeah. So that's how you tend to use machine learning as part of data science.
Okay, sir. Next is an interesting question. Can machine learning actually conquer over human?
Yeah, that is a tough field, tough question, because see, I don't want to get into debates. If you use any technology wrongly, see, a knife in the hands of a 2-year-old could be very dangerous. We don't know what they will do. But typically, knife in the hands of a little bit, adult might not be that dangerous, but they could make it dangerous also. So similarly, this field is like that. So if you use today, if you see, we are getting into autonomous weapons systems and all, and it could basically be very dangerous. Autonomous systems could be like very dangerous where where there is no human involved on one side, whereas automated machines are on the other side and humans are on one side. It could go wrong provided we do not apply it properly. So it's not the problem with machine learning. It is how we apply the machine learning to what type of problems we want. Very, very important actually. Yeah. So I don't know, human existence itself. People have predicted that human existence, machine learning could be a threat to, or AI as general, because when we talk machine learning, we typically people correlate it to artificial intelligence, because it's a sub branch within the field of AI. So there are people who have predicted that, AI forms an existential threat to human beings. So that way, yes, answer is yes. But I would not worry much about it at this point in time. But we need to, governments and the people working in the field need to ensure that they use it for ethical purpose, or we are responsible for what we do, in the field. So today AI is used for surveillance and other things. I don't know whether it's a great idea, because surveillance should not be used to suppress the citizens, in which case that becomes authoritarianism, So yeah, so that would be my take. To frankly speak, I don't know the real answer, but there are some threats involved,
Okay, sir. Next question also is something similar to that. How does the world change with machine learning?
Yeah, so machine learning today, if you see, automation is one of the foundations by which we basically, because ultimately machine learning is learning about patterns and using those patterns to take actions. So once we are good at it, we can automate this entire stuff actually. So today, autonomous car. So what is the impact of autonomous car? Let us say we get into level 5 autonomy for cars. It is a big threat, because if you see, maximum people in the world today are employed in driving. So if you automate the entire driving process, basically tomorrow somebody like Tesla comes and says we have mastered level 5 autonomy. You will not have steering wheels, You simply sit in the car will go. And I think that might threaten a lot of people and stuff. So automation is where this is getting applied a lot. And depending on situations, we might see, I won't call it job loss, I would call it job shift. So probably certain jobs will go away, certain other type of jobs will come. Unless you are willing to learn and adapt it, people will be basically, getting into situations where, you will lose your job at the age of 50, in which case, you can't get a job. Because when you are young, if you lose the job, it is easy to get a job, new job. But when you are in your 40s and 50s and you lose your job, it is very, very difficult, because you tend to lose your job because you do not have certain, skills or capabilities. You are a driver, now you lose the job. What else can you do is a question mark, Can you become a plumber, Now if they automate that job, what will happen, So you will have to adapt it. So there are some risks. So there are many ways AI is used today. There are thousands and thousands of use cases for AI today.
Thank you, sir. We'll move to the next question. What are the scopes of machine learning?
Scope?
Yes, sir.
Yeah, there are, as I said, you could be, when we talk about machine learning, you could be a person who's applying machine learning to a business field. You could be developing the algorithms per se. You could be developing the hardware for this machine. So there are different roles and scopes that are available from an individual perspective. Which one should you choose depends on your taste, So I showed you many different roles. You could be a systems engineer, or you could be somebody developing the chip itself, which is used for the pattern recognition, So I think that depends on your taste and what you want to become,
Thank you, sir. The next question is something specific. What are all the techniques are available to enhance the text classification using machine learning?
Okay. So text classification, see, there are two schools when it comes to NLP. So one is the traditional school. Let me see if I can figure out. And one is the deep learning school of thought, which is the newer one. So there are quite a few algorithms. So text classification. So if you want, take a look at a library called Hugging Face. So Hugging Face is stuff. So there are quite a few algorithms for you can take there are quite a few algorithms. So depending on what type of text you have, what type of a noise you have, how much of algorithms you have, there are quite a few algorithms. So this is the deep learning way of doing text classification. But if you are an old school person, you still could use what is called the traditional methods using TF, IDF type of things, term frequency, inverse document frequency. So there are different areas, so there could be, see, if you look at classification from a text perspective, it could be syntactical classification, semantic or pragmatic classification, So more of deep learning comes in somewhere in between syntactic and semantic. Some of the older traditional techniques, bag of words techniques will be still considered more syntactic. So I would say search for text classification. There are quite a few algorithms also, you could take digital BERT. So there is an entire thing called sentence BERT. Actually, you can take it. So this is another one. SafeIt, very very important algorithm. Efficient few short learning without prompts. Actually, it is used for text classification where you have very little data actually, and it is compared against different algorithms available to see what type of accuracy comes when it comes to sentiment analysis or other type of text classification. So let me put this for you, and you can take a look at the entire Hugging Face library for more. So I'm putting it in the chat actually. Yeah, so there are two methods, traditional method and the deep learning method. So Hugging Face will come in picture for deep learning method. Traditional method, you can search for it. Like you can search for bag of words methods or things like TF, IDF, you will get it,
Thank you very much, sir. These are all some of the questions we have received from our participants. So thank you once again. Thank you very much for your excellent way of answering. Now I will request.
Rajeev, I have one small question regarding, see, now machine learning heavily depends on the data, right?
Yes.
Now a lot of noise is there about synthetic data. How does it have an impact on machine learning? Because synthetic data is again developed by algorithms, right?
Yes, absolutely.
So the algorithm design data, and how does it predict the actual model? Now, will it have any? Of course, you touch about bias. So how to avoid any negative impact of this synthetic data?
Yeah, see, negative impacts only can be avoided if you test it out properly, But where the synthetic data is predominantly used, you see, there are many areas like medical field and all where data is far less. So you will have to augment some areas like that with synthetic data. But ultimately, it is the pattern that the data learns from. So if you show a cat or a dog, how does the machine learning algorithm learns? It could learn the color. It could learn the shape. It could learn the relative positions of subcomponents actually, which could be like how is the eye related to nose or nose related to ear and things like that. So synthetic data could generate the data in the form which is required, but ultimately a machine learning algorithm in turn tries to identify the patterns that differentiates one data segment from another data segment. So the entire field started becoming more popular with probably like 4 or 5 years back. There was something called GAN, a type of algorithm generated which is called generative adversarial networks,
Yeah,
yeah. So GANs are actually the main reason why today we are talking about synthetic stuff. So what they do in that is that they put two algorithms to compete each other. One will generate data, other will predict whether it is fake or not. So
Okay.
it learns the population the distribution, data distribution internally, which allows it to basically generate more data. Yeah, a very, very important field, and we might see this being extremely useful for areas like metaverse and all. Where I want to create an avatar, I could generate an avatar myself, and then basically use that avatar in my metaverse journey.
Okay.
Yeah.
Yeah. There is one last question. This Major Tajuddin has asked, in any organization, what steps would you recommend for creating a conducive ecosystem for machine learning?
In companies?
Yes.
Yeah. So typically, if you look at how TCS and all evolved, it started with research. So in research, again, it's mostly innovation on certain specific fields and stuff, but revenue generation might not be extremely good. Then from pure research, you get into what is called proof of concept or proof of technology. Where you try out at customer locations, but you will still might not generate the revenue required for you. Then you will get into project implementations once the technology matures and you are able to solve the problem. So it follows I would say research first, trying it out through proof of concept and proof of technology, and then taking it to engineering scale. How do I deploy it in large scale and stuff like that? So it follows some standard stuff, standard steps.
Okay. So, which means that some research could retire before find its application possibility.
Yes. So not all research make it to production.
Yes.
I would say like 90% research might not make it to production, less than 10%. It is more like a startup. If you have 100 startup, only 10 will succeed.
Okay. Yeah, I understand. Yeah. So nice. Thank you, Rajeev, for a wonderful presentation. Now I request Mr. Kamalakkannan to deliver the formal vote of thanks. Okay.
Yeah, thank you, sir. Good evening, everyone. Mr. Raju, please accept my congratulations and thanks for this wonderful presentation. Thank you for accepting to speak on a Saturday. And this is one of the recent, out of the many recent events, I think this is the one which has attracted, I would say, many people. Close to 50 are on this call, and many more are watching on the YouTube. So I'm sure this has excited a lot of interest in the people, and you have met with all the satisfaction, all the expectations of the people. So thank you very much, Mr. Rajeev. And
Thank you, sir.
And also the way you dealt with the whole presentation was also very practical. I mean, you did not delve through a library of algorithms and talk about it, because there are so many in the world. People talk about it and they debate about it, but you actually helped people to navigate the practical way by which ML can be implemented. Right? You started with the end-to-end ops. You had a beautiful. Actually, I like the three of your charts. One is this end-to-end ops, starting from the business and wading through data and sustainability, the infrastructure. I mean, beautifully done actually. So that circle, concentric circles, is a beautiful diagram. Similarly, the other one, the stack that you had showed, right? ML stack. Again, starting from the technology, the silicon, then the kernel, then the software tools. Lovely presentation, Mr. Raju. And you also told us how to go through the various stages in ML also, right? How do we start with the requirements and how do we actually go up to implementation? So I think you have demystified the world of ML today. Thank you very much. And the questions were also very interesting and you fielded them very well. And you also highlighted the dangers of such technology. I mean, which is always a side effect of any technology, especially when it is upcoming. And finally, you beautifully answered Mr. H.R. Mohan's question on synthetic data. So on the whole, I think we had a very enlightening presentation by you. So on behalf of Computer Society of India, Chennai chapter, ACM, and IEEE Computer Science, we would like to thank you for participating in this and enlightening the world of ML. And I would also like to thank all the participants who joined in spite of this being a weekend, and also all the members from all the three organizations. So thank you all very much. Once again, Mr. Raju, we'll be in touch with each other, and I'm sure there will be a lot of people who will be in touch with you to take it forward. So thank you all. Thank you very
Thank
much.
you, sir. Thanks.
Thanks, Rajeev.
Thank you. Thank you, everyone. Bye.
Yes, yeah. Stop. Okay.
Yes, ma'am. Thank you.
Okay.
Bye.
Bye bye.